Welcome to the most comprehensive series on limits. In the last few parts, we had discussion on the basic concepts of limits. We went into some problem types like LHL, RHL and used it to solve questions based on modular's greatest interior function. Then we went into techniques like factorization, rationalization and how to solve infinite limits. In the current one, we are going to learn about the Brahmastra of limits, that is series expansion. So without any further delay, let us quickly start with it. So in type 8 problem type, that is series expansion, first we should understand how to write certain types of series expansion. So let me show you for e raised to the power x, what is the concept behind it. So if we have a function e raised to the power x, we can approximate it using an infinite series. So it can be written as nothing but a naught plus a1x plus a2x square, we can go till infinity. So it is an infinite series. Once you have done that, the only thing that we don't know are these coefficients, that is a0, a1 and a2. So we are trying to approximate. See, realistically speaking, we can't express an exponential series into a sum of an algebraic series. But here we are able to do so because it is an approximation, it is not the real thing that we are trying to do. So now once we have understood that, now the idea would be to find out the value of a0, a1, a2. A simple technique to do that would be, in the first iteration, what we are going to do is put x equal to 0. And this is a standard thing that we do in order to get the value of constant. So if I put x equal to 0, on the left hand side we have got e raised to the power 0, on the right hand side we have a0. So we have got the value of a0 as nothing but 1. Once you have got that, we can do the next part. So for the next one, now in the next iteration, we can differentiate it both the sides. So if I differentiate, dy by dx of e raised to the power x will come. And then derivative of a0 plus a1x plus a2x square, this will come. So if I differentiate it, this comes out to be e raised to the power x. This becomes 0. This becomes a1, then 2a2. X and then so on and so forth. Now again we'll do the same thing that we did earlier. We'll again put x equal to 0 in this, because now we can see that a1 has become constant for this new series. If you do that, left hand side becomes e raised to the power 0, right hand side becomes a1 plus 0 and all other terms will become 0. So the value of a1 again comes out to you. We have done it 2 times, let us do one more time. So third time is a charm. Again, now whatever we got here, this series we are going to differentiate. So we are going to differentiate e raised to the power x on the left hand side. And on the right hand side, what we have is nothing but a1 plus 2a2x, so on and so forth. And if I repeat it, left hand side becomes e raised to the power x, this will become 0, this will become 2a2. The next part will become 2 into 3 x. And so on and so forth. There would be an a3 as well. So let us write a3, then 2 into 3 times x and then other terms. You can see that now what is happening. Again, I can put again x is 0, because now you can see that a2 has become the 2a2 has become the constant term. So the left hand side becomes e raised to the power 0. This will become 2 times a2 and rest of the terms will again become 0. So the value of a2 again becomes 1 by 2. If I keep doing this process, we come up with a series that looks something like this, and this is very important because once we remember this, we will be able to figure out the rest. So the series expansion of e raised to the power x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, so on and so forth till infinity. You can see that whatever is the power over x, the same factorial we are getting in the denominator. This is easy way to remember this series. See, once you have got this series, similar method we can use and get all of these series also. Now out of these, there are few that are very important, like this would be useful. This would be useful. This of course is useful. Sin x, cos x, tan x, and rest of the things, most of the times we won't be able to apply that much. So this, if I write, remember it is fine, remember if it is fine, remember fine. But this is something that we already know. This is a series expansion of binomial expansion. So you can clearly see that most of the series you already know. It is not very difficult. And the rest of them, like the first 4 or 5, I will tell you a technique to remember it. So there is a technique because we will use whatever we remember in solving problems. So let us learn that technique. So we already knew what was the series for e raised to the power x. Whatever is in the power of x, put that in factorial notation in the denominator. So x square by 2 factorial, x cube by 3 factorial, so on and so forth. Now you can see that the first one that we can get out of it is nothing but a raised to the power x. So if I want to get a raised to the power x, what we are going to do? We are going to replace a x by x ln a. If I do this one thing, I will be able to get my answer. So if I do this, this becomes 1, this will become x ln a by 1 factorial. The next part will become x ln a whole square by 2 factorial, and like this it will go on. So by doing this one change, you get one more series. Next would be nothing but sin x. So out of this, what we have got, if I just take the odd power terms, so this is the odd power, this is the odd power, and write it here. So I can write x by 1 factorial, x cube by 3 factorial, x raised to the power 5 by 5 factorial, so on and so forth, and put alternate plus minus sign. Alternate plus minus plus. So you get a series for sin x. It is very simple, odd power terms. Similarly, if I want to get it for cos x, now I am going to take the even power terms. So that would mean I will consider 1, then x square by 2, these terms I will write. So if I write this, I get 1, then x square by 2 factorial, x raised to the power 4 by 4 factorial, so on and so forth. Put alternate plus minus sign. We have got the next one also. Then the fourth one was ln of 1 plus x. So once you have got this, what now we need to do is basically take all the terms but remove the factorial sign. So what we are writing is x, then alternate plus minus sign. So x by 2 plus x cube by 3 minus x raised to the power 4 by 4. You can see that the first 4 important ones we have already got. This was for a raised to the power x, we have already got it. E raised to the power x, we already derived it. By the way, each of this can be derived using the method that we wrote earlier, that is known as Taylor's method. So each of this can be done using that method also, but most of the times will require this to remember in order to apply. Here you can see that it is the same thing, alternate plus minus sign, and the factorial is gone. This, if you remember, it is an additional benefit in some other questions. And this again you can see, this also we figured out, this also we figured out. Only thing that we haven't figured out and until now is the 10x wala part. So for this, just remember these two terms, x plus x cube by 3, very easy to remember. And the next one you will almost never use. So again, this one also you can easily remember. So till this time, what I have told you, let us recap and then move forward. So what I have told you is one, the Taylor's formula or Taylor's method to get series expansion. I took one and did it. You can do all using that. Second, we had some standard series expansion using that. We had some standard results that we can use in solving problems. Third, what I told you was a technique to remember all of those results, because we will need to remember, that is very important. Only thing that we are unable to get out of that technique was 10x, and that also we can easily get by remembering these two terms, x plus x cube by 3. Using these three ideas, now let us look into the problems and how can we solve them. The first problem is given to us if I want to solve it. Now in this question, what we can do is write the series expansion of e raised to the power x. So if I do so, the terms can be written as 1 x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, x raised to the power 4 by 4 factorial till infinity. Then you will have minus 1 minus x, and then in the denominator we will have x square. So you can see that now once you look into this, these two terms will get cancelled out. Once these cancel out, what are we left with? Is limit x tends to 0, x square by 2 factorial, x cube by 3 factorial, x raised to the power 4 by 4 factorial, and then divide by x square. If we simplify this, what have we got? Limit x tends to 0, 1 by 2 factorial plus x by 3 factorial, then again x square by 4 factorial. And now what we can do is put x equal to 0, and as a result 1 by 2 factorial remains. Other terms will become 0 and answer becomes 1 by 2. It is very simple. What are the steps? Take whatever term is there whose series expansion we know, substitute that series expansion, then simplify and get the answer. It is as simple as that, and that is what makes it the Brahmastra of limits, because you can just fire and forget, the work would be done. Only thing is sometimes the solution will become lengthy. Okay, so that is the reason most of the times we will not try and use it, or use it as a method of last resort, but it is highly useful in solving a large variety of problems. So now another thing that we need to understand here, there is a shortcut into place. Let us understand what is the shortcut. So see, in order to solve this, calculation will become much simpler if you notice a very simple thing. These terms which were more than x square in the numerator, ultimately we wrote it down here as well, and then you can see that all of them became 0. So important thing to note is, even if I don't write these terms greater than x square power, it is not going to make any difference. Okay, so let me write it down and show you what I mean. So what I am saying is, what you need to consider for series expansion is, consider power of x that are smaller than or equal to smallest power in denominator. Okay, only consider those powers in numerator, x in numerator, which are smaller than or equal to the smallest power in denominator. So let me show how it works out now. So instead of writing what we wrote earlier, now we will write only till x square. So this becomes 1 by x square by 2 factorial minus 1 minus x by x square. And as a result, first two terms cancel out. It becomes limit x tends to 0, x square by 2 factorial divided by x square, that becomes nothing but 1 by 2 factorial. You can see that the solution became much smaller to write and implement. Now let us see how this works out in this next question. So if I look into this question, again I will want to write series expansion of these three terms first. If I write it down, let us see what do I get. So let us start from the denominator, because that will tell us how many terms to go behind. So x minus sin x, if I write, this will become x minus sin x expansion is x minus x cube by 3 factorial plus x raised to the power 5 by 5 factorial, so on and so forth. If I simplify this, this x will get cancelled out. This becomes x cube by 3 factorial minus x raised to the power 5 by 5 factorial. You can see that the smallest power of x in the denominator is x cube. In the denominator, see, denominator is important, you can't randomly do it. So what I am trying to tell is, to get the answer, I do not need to take powers of e raised to the power x more than x cube. So I can write till 1 plus x square by 2 factorial plus x cube by 3 factorial. Similar thing I can do for e raised to the power minus x. So what I will do, in order to get this expansion, I will replace x by minus x. So in place of x, I have written minus x. In place of x, I have again written minus x. And in the third term also, in place of x, I have written minus x. If you do it so, this becomes 1 minus x plus x square by 2 factorial minus x cube by 3 factorial. This is what we have done. Once you have all of these material into place, in the next step, I can just substitute and get the answer in one line. So limit x tends to 0. The first part can be written as 1 plus x square by 2 factorial plus x cube by 3 factorial. The next part would be written as 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial. And then what we have is 2x. In the denominators, you can write all of these, but even if you write the one with the smallest power, that would be more than. Now, once you have done this, you can see that all of these terms are getting cancelled out. 1 will get cancelled out from here. This will be x, 2x will get cancelled out from here. Then x square by 2 from here, and here will get cancelled out. So, ultimately what you are left with is limit x tends to 0. 2x cube by 3 factorial. We have x cube by 3 factorial in denominator. Cancels out, answer becomes 2. So, you can see that taking expansion till right power makes our calculations extremely easy. Moving forward, we have been given this question. Now, if you have got it, you can just start solving it. But if you haven't got it still, let us try and solve few more questions. Like in this case, so you can see that in the same question also, we can take expansion of the same term to different powers. Numerator we will consider differently, denominator we will consider differently. So, for writing into the denominator, that we should do first. Now, you can see that I am directly doing series expansion. I am not writing them down separately and then putting it here. I will only consider the minimum most. So, 10x expansion is x plus x cube by 3. So, since it is in the denominator, only I am considering the first term. So, I will write only x here. As a result, it becomes x raised to the power 4. And now you know that in this expansion, the next term would be x raised to the power 5. So, in the numerator, when I will write 10x, I will consider two terms, x plus x cube by 3 whole square minus x square. So, see this choosing in the same question, we can take till two different powers also. Now, once you have done this, limit x tends to 0, expansion of numerator becomes a square plus b square minus 2 ac. So, this will become x raised to the power 4 by 3 minus x square by x raised to the power. So, you can see that this will get cancelled out. In the next step, we will be able to cancel out 1 x raised to the power 4. So, this is x square by 9 minus 2 by 3. This should be plus sign. Yeah. So, once you have this, x can be substituted as 0, answer becomes 2 by 3. We have got our answer. You can see that this is a very important idea. Now, sometimes question of this type will also come. We have already seen questions of this type earlier, but now we will change the technique in this question. So, what I will do is again write series expansion, and you already know it needs to be done only till the lowest power in denominator. So, becomes a into 1 plus x minus b by x. In the next part, this is equal to 2. We can write limit x tends to 0. Separate the power. So, this will become a minus b plus ax by x. We will do the same thing what we did earlier. See, for this limit to exist, if I put x equal to 0, you can see that a minus b would be left. If his x is tending towards 0, this will be x minus b by 0. For this to have a finite answer, what should happen? A minus b should be equal to 0. A comes out to be equal to b. This is important. Now, solving forward, this becomes limit x tends to 0. Ax by x is equal to 2. X cancels out. The value of a comes out to be 2. Once a is 2, b also comes out to be 2. And as a result, a is equal to b is equal to. This is the final answer. Again, this is a more advanced form of the same question that we just did. We'll use the same technique. Now, here sin x expansion. Now, again, keep a note how I'm choosing the powers. That is a crucial part of getting the answers shorter and faster. I will only take the lowest power because it is in the denominator. That gives us an understanding. Now, e raised to the power x also need to be written till x square. So, till x square by 2 factorial we have written. Similarly, for the next part, minus b, cos x can also be written till the second power. And then c times e raised to the power minus x will also be returned till second power. Okay, this should be equal to 2. See, now if you simplify this, what is the idea? What we did earlier, same thing. We'll write the constant terms. So a minus b plus c. And then other terms, a minus c into x. Then the remaining terms, a by 2 plus b by 2 plus c by 2 into x square divided by x square is equal to 2. Now we can see that all the smaller powers in denominator, these should be equal to 0, otherwise it will become infinite. So if I again export x equal to 0, you can see that the same thing will happen. So all the powers that are smaller than x square will have to become 0. So a minus b plus c will become 0. And then a minus c will also be equal to 0. Otherwise it will become infinite. That is the reason we are doing it. Once you have got so, now we can solve this limit. So this comes out to limit x tends to 0. A plus b plus c divide by 2 into x square. We have 1 x square in the denominator, cancels out. So the value of a plus b plus c is equal to 4. You can see that now we have 3 equations, 3 unknowns. Let us try and solve them and get the final answer. So in the next part, this was my first step. This was my next step. And this is my third step. I will solve them out. What I have is, using second equation, a is equal to c. If I put that in the first one, becomes twice of a is equal to b. And if I put all of these in the first equation, third equation, a is fine, b will become 2 times a and c is also a. This is equal to 4. So clearly from here, 4a is equal to 4, a comes out to be equal to 1. Once a is 1, c also comes out to be 1 and b also comes out to be 2. So now we have got the value of ABC. Moving forward, now there is question that is given in this format. Now this looks a little bit weird because most of the times when we are solving questions earlier, there was x tends to 0. This first time you can observe that instead of 0, we have been given x tends to 1. So it is very important that we restore the order of limits by putting a substitution. So now first step has changed. We are doing substitution first. So x we are putting as nothing but 1 plus h. So now when x tends towards 1, as a result h will tend towards 0. So the limit has changed now. Limit h tends to 0. This will become 7 plus 1 plus h raised to the power 1 by 3 minus 2 divided by 1 plus h minus 1. Next step would be, this is the second step, limit h tends to 0. Now this becomes 8 plus h raised to the power 1 by 3 minus 2 by h. In order to solve this limit, it would be easier if I take this 8 common from here. I will tell you what is the reason for doing so. So this becomes 1 plus h by 8 raised to the power 1 by 3 minus 2 by h. Now this h, 8 will have the power of 1 by 3. Now why did we do this? Because from series expansion point of view, from all the results that we had earlier, let us go back to those results. You will be able to notice that this corresponds to the result of 1 plus x raised to the power n, or this binomial expansion. So this result will have to use in this case. So for this result to be applied, in this result we'll want 1 plus x here. And that is the reason we have considered it. Now let us go back and see how to move forward. Once you have got this, the next step would be very simple. We are going to use our series expansion. So in the next step, what we are doing is, we are writing 1 plus x raised to the power n expansion. If you have this, I can write this as 1 plus nx. And I will only have to go till 1 power because denominator has 1 power. If it had not be the case, we will write this as n into n minus 1 by 2. Series, simple binomial expansion like this. But since the power is only till 1, we will take the first 2 parts only. As a result, what we have got in the third step is limit h tends to 0. This will become 2. this can be written as 1 plus 1 by 3 into h by 8 minus 2 by h. And if you simplify this, we have got our answer. You can see that 2 will get cancelled out. This will become h by 12 by h. So answer becomes 1 by 2. This becomes the answer. Now, a more complicated form of the same question is again given here. If I want to solve this, again I will do the same thing. I can put h as nothing but 2 plus h in the first step. If I do it so, the limit changes to 0. And as a result, this becomes 14 plus 9 times 2 plus h raised to the power 1 by 5 minus 3 times 2 plus h plus 2 raised to the power 1 by 3 divide by 2 plus h raised to the power 1 by 2 minus 5 times 2 plus h plus 6 raised to the power 1 by 4. If I further simplify it, this becomes limit h tends to 0. This becomes 18, 9 into 2, 18. Then 18 plus 14 will become 32. And we have got 32 plus 9h raised to the power 1 by 5. The next part becomes, this will become 6 plus 2, 8. So 8 plus 3h raised to the power 1 by 3. Divide by, this will become 4 plus h raised to the power 1 by 2. And the last one will become 16 plus 5h raised to the power 1 by 4. The easier thing to be done, that is the next step would be to take it to the standard form, that is 1 plus x form. So, uske liye we will have to take 32 common. So, 32 raised to the power 1 by 5. 1 plus 9h by 32 raised to the power 1 by 5 will come. And 8 raised to the power 1 by 3. 1 plus 3h by 8 raised to the power 1 by 3. Divide by 4 raised to the power 1 by 2. 1 plus h by 4 raised to the power 1 by 2. And then 16 raised to the power 1 by 4. 1 plus 5h by 16 raised to the power 1 by 4. Once we have this, life has become quite simpler because all of these terms are equal to 2. Whether I take the first one, second one, third one or fourth one. Once you have this, this will get cancelled out. And we get a very simple form. First one becomes 1 plus 9h by 32 raised to the power 1 by 5. 1 plus 3h by 8 raised to the power 1 by 3. Divide by 1 plus h by 4 raised to the power 1 by 2. And lastly 1 plus 5h by 16 raised to the power 1 by 5. Once you have this, now the series expansion that we learned, that we are going to apply in third part was 1 plus x raised to the power n can be written as 1 plus nx, and other terms also will only consider first two. If it does not work out, we will consider taking one more. But I think this should definitely work out. Limit h tends to 0. This will become 9h 1 by 5 times 9h by 32 minus 1 minus 3h by 3 into 8. And then in the denominator 1 plus h by 8 and then minus 1 minus 1 by 4 into 5h by 16. You can see that now this 1 will get cancelled out, and as a result what happens to this is, what we are left with is 9h by 5 into 32 minus 1 by 8 into h. Denominator becomes 1 by 8 minus 1 by 5 by 64 into h. So this h again gets cancelled out, and if you simplify this, you get minus 34 by 10. Fine answer. You can see that similar process, but a more complicated application. Now let us look into this 2024 JEE question that came on this idea. So again, a clear-cut question on series expansion. Now most of the times, the student who don't know this will directly apply L'Hopital rule. It will become such a lengthy question to solve, and then they will give up after some time. Now let us look into this question. Now in this question, we know that for the denominator part, we'll take the minimum power of x. So in the first step, if I write series expansion, we always need to start it from the denominator. So this can be written as x squared, this will become x. Now we understand that the maximum power we need to consider in the numerator is x cube. So this part is fine. What I have to do is basically consider it till x cube. So 1 plus x is fine because x square will get multiplied and make it x cube. Then minus b, this we can write as 1 x minus, not 1, x square by 2 plus x cube by 3. And then this can be written as cx is fine, 1 minus x plus x square by 2. So now you can see that numerator की maximum power is going till x cube, and now it is totally fine, and this they are saying that should be equal to 1. So in the next part, what we are going to do is going to write it in the ascending power of x. So there is no constant term that I could see, but if I just look into the power of x, so we'll get one power of x from here, another from here. If I want to just write the power of x, this will become c minus b into x. If I want to write that for x square, that would be nothing but a, then plus b by 2 from the next term, and then minus c from the next term. And then finally, the coefficient of x cube we can write. If I write that from the first one, we'll get a. From the next part, we'll get minus b by 3. And from the last part, we'll get c by 2 into x cube. Now, the process is very simple. I told you this earlier also. All the powers of x that are less than the denominator. So, this part, should be equal to 0. And if I do it so, c becomes equal to b, and then again a plus b by 2 minus c also becomes equal to 0. So if I do so, what is left in this limit is nothing but limit x tends to 0, a minus b by 3 plus c by 2 into x cube divided by x cube. This will get cancelled out. We have got our third equation as well. A minus b by 3 plus c by 2 equal to 0. Now you have three things and three knowns and three unknowns, three equations and three unknowns. We'll solve them to get our answer. So let us see what do we get in the fourth part. So the first equation that we have got is c is equal to b. If I put it in the next one, this will become a plus b by 2 minus b is equal to 0. So a would come out to be equal to b by 2. If I substitute this in the third equation, let us see what do we get. In place of a, we will have to write b by 2. In place of b, b by 3 is written. In place that next term is c by 2. That will become b by 2. This is equal to 1. If I add these two, becomes b. b minus b by 3 will become 2b by 3. And as a result, the value of b comes out to be 3 by 2. Once you have this value, let us figure out the value of 16 times a square b square plus c square. Now we know that a is equal to b by 2, b is 3. So this becomes 3 by 4. B is 3 by 2, so becomes 9 by 4. And c is equal to b, so this becomes also 9 by 4. So if I simplify this, let us see what do I get. So if you multiply 16, the first term would be 9, the next term would be 9 into 4, and the next term again would be nothing but 9 into 4. and as a result this becomes 36 plus 36, 72. 72 plus 9, that is equal to 81. So answer to this question becomes 81. Moving forward, another question in 2024 says that we'll have to solve this limit, figure out the value of m and n, and then answer the question that is given to us. You can see that this is the similar kind of question that we did earlier. So what we can do in the first step is do the substitution. Put x as 1 plus h. So when x tends towards 1, h will tend towards 0. So this question becomes limit h tends to 0. 5 plus 5h plus 1 raised to the power 1 by 3. The next part becomes 1 plus h plus 5 raised to the power 1 by 3. And the next part in the denominator becomes 2 plus 2h plus 3 raised to the power 1 by 2 minus 1 plus h plus 4 raised to the power 1 by 2. So if you simplify this, limit h tends to 0. 6 plus 5h raised to the power 1 by 3. This becomes 6 plus h raised to the power 1 by 3. The denominator becomes 5 plus 2h raised to the power 1 by 2. And then the next part becomes minus of 1 plus 2h, 5 plus h raised to the power 1 by 2. Once we have this, we can take common. From the numerator, 6 can be taken as common. So 6 raised to the power 1 by 2. Denominator 5 raised to the power 1 by 2. As a result, numerator becomes 1 plus 5h by 6 raised to the power 1 by 3. 1 plus h by 6 raised to the power 1 by 3. Divide by 1 plus 2h by 5 raised to the power 1 by 2. 1 plus h by 5 raised to the power 1. Now, once you have done this, the next part would be to put the limits and do the usual thing. So this 6 raised to the power 1 by 3 and 5 raised to the power 1 by can be parked outside. Inside the limit, we can put series expansion. We did this earlier also, can be written as 1 plus nx. So becomes 1 plus 5h by 18. This will become minus 1 minus h by 18. The remaining part becomes 1 plus 2h by 10 and the last becomes 1 minus h by 10. You can see that 1 gets cancelled out and we are left with a very simple limit. Limit h tends to 0. You have 6 raised to the power 1 by 3 and 5 raised to the power 1 by 2 parked outside. And now this h will also get cancelled out. So what you have is 5 by 18 minus 1 by 18. This becomes 4 by 18h. And in the denominator, you have 2h by 10 minus h by 10 becomes h by 10. H gets cancelled out. So we have 6 raised to the power 1 by 3 by 5 raised to the power 1 by 2. 4 into 10 by 18. Now let us revisit the question and see what is given, how we can rewrite it to get to an answer. So if I simplify this, you can see that we have 9 here. So 2, there is a possibility of 2 getting cancelled. So this becomes 5 and then this becomes 9 like this. So this can be definitely cancelled out. So this will become 8. Why are we doing it? Because you have 6 raised to the power 1 by 3. It needs to be adjusted in the denominator. So 1, we can write this as 6 into 3. If this cancels out, this can be written as 6 raised to the power 2 by 3. So 8 root 5, this part is fine. Then you have 3. This can be written as 2 into 3 raised to the power 2 by 3. If you clearly compare now, the value of m comes out to be 8 and the value of n comes out to be 3. The question says that what is the value of 8m plus 12n. So 8m will become 64 and 12n will become 36. Answer comes out to be 100. Now let us look into this next very interesting question. In this question, what we have been given is cos x into this whole term is given. So let us first understand how to simplify this part, because if you are able to simplify this part, it would be much simpler. And before that, let us take only one out of that. Let us only this last one and simplify this. This will pave the way for simplifying the remaining part. So what we have is cos 10x raised to the power 1 by 10. I can write this as 1 minus x square, है ना? तो in the series expansion, in place of x, since 10 is written, तो 10x का whole square by 2 factorial, this can be written. Now once you have written this can easily be simplified as 1 minus 100x square by 2 factorial. In this manner we can write it, and beyond this we do not need to go, because the lowest power of x in the denominator is x square. So like this, if I do it for cos, before that 9x will come raised to the power 1 by 9. Fast forward whole process, this will become 9 square x square by 2 factorial. And like this I can keep writing for all the terms. If I write it and then substitute, let us see what do I get. Let's first do the calculation, then substitute. So if I put it in this part, that is cos of x, then cos of x raised to the power 1 by 2, 2x, and in all of these terms, if I put these values, the first will become 1 minus x square by 2 factorial, 1 minus 2 square x square by 2 factorial divided by 2. The next one, there would be 1 by 10 also here, that would be 1 by 9 also. And this will also get cancelled out, this will also get cancelled. So you can see that what is happening when you are writing these terms. These terms are getting cancelled out, and as a result, what you have got here is 2 into x square by 2 factorial. Every time you are writing a term, you will just write that power, that coefficient of x, like x, 2x is there, तो x 2 लिख देंगे, 3x is there, तो 3 लिख देंगे, x square by 2 factorial. And this will keep on writing till 1 minus 10x square by 2 factorial. If you multiply this, you will get multiple terms, but more importantly, till x square. When you multiply these two, you will understand what will happen. These two terms will get, so this would be, and if I am multiplying 1 plus a, 1 minus a into 1 minus b, what is happening? I will get 1 minus a plus b plus ab. So see, this term we don't want. We just want the first two terms, these two terms. You can see that क्या बच जाएगा, 1 by 2 factorial plus 2 by 2 factorial plus 3 by 2 factorial. Like this it will go till 10. And after this, higher powers will come that we don't require. Once we have written this, you can see that this can be simplified as sum of n natural numbers till 10, so n into n plus 1 by 2 into x square. So these higher powers I have neglected because x is tending towards 0, and in limits we do that. So once I have got this, in the third part I can substitute it. So limit x tends to 0. You have 2 times 1 minus, if I substitute the value becomes 1 minus, this is 55 x square by 2 divided by x square. 1 gets cancelled out. After simplification, this will become plus. X square will also get cancelled out. So this becomes limit x tends to 0. This becomes 55 x square by x square. The answer becomes 55. This is what we are getting. Now we can clearly see that using the similar kind of technique, this question is almost same as the question that we solved earlier. I think you will be able to solve this question using the technique that we used earlier. Moving forward, you can again see that this is also a similar question that we solved earlier. So I don't think any kind of addition or alteration is required in this question. This also you can do based on the question that we have just solved. This question also is again the similar kind of question that we have solved. So I don't think this also requires further application from my side. And this also is a repetitive question that came on to 22. You can see that the pattern of the question has been almost same in the last few years. One question that we are going to solve is this last question that came into 2024, because you can see that here there is a different kind of series expansion that is involved. So we'll have to understand what does this mean. So let us write this term separately. Everything is fine. It is just on the power we have 1 by 2. How to write this series expansion? So I can take this series expansion as s in the first step and then take log on both the sides. So this becomes log of 1 plus 2x raised to the power 1 by 2x. And as a result, this can be written as 1 by 2x. And then you have log of 1 plus 2x. Now, if I want to simplify this, 1 by 2x is fine. The series expansion can be written as x minus x square by 2 plus x cube by 3. Okay. So we can do it like this. And now if I simplify this, 2x will get cancelled out. And what we have left is 1 minus 2x by 2 plus 2x whole square by 3. Now we can see that this is for log of s. So if I want to get it for s, I will have to take it on the power of e. E raised to the power 1 minus. This will become x. After simplification, this will become 4x square by 3. This is e into e raised to the power minus x plus 4x square by 3. And now let us do the expansion. Let us see what do we get. So you can see that since the highest power is x only, so x square we do not need to consider. Even before doing that, I can write it like this. And as a result, the series expansion becomes e into 1 minus x by 1. Beyond that, so in the next part of the question, I can do this substitution and get my answer. So limit x tends to 0. This becomes e minus e into 1 minus x by x. If I simplify this, this comes out to be limit x tends to 0. E minus e, so this will become ex by x. Answer comes out to be. So let us see. You can see option D. Again, using series expansion, we can get this extremely fast. In this video, we went into the depths of series expansion, how to apply it, how do we get the basic results, and how to apply it into typical JEE problems. In the next one, we are going to look into trigonometric limits. I highly recommend that if you are watching this series, do practice the remaining questions that are there in the lecture notes uploaded with this video. I will also highly recommend a course that we have made in problem solving. So in case you are one of those students who is still not satisfied, there is a detailed course, the link of which I have put it in the description. You can go over that course also. I think it would be highly useful to you. For the students who are still looking for some kind of doubts, I will highly recommend that you get in touch with one of the Pragvi team members and see how we can write a customized planner for you to help you out. See you until next one.